Good afternoon, and thank you for sharing your lunch break with me. It's very kind of you to come along. I'm based in London in the UK, but I contribute to quite a few OWASP projects. I'm a co-project leader of OWASP AppSecUSA project. I'm the project leader of the Codes of Conduct project, and also two security training awareness games, one of which is OWASP Cornucopia, which is a sort of threat modelling card game, and also a sort of fun OWASP Snakes and Ladders board game. But today I'm going to talk about a new OWASP project which I started earlier this year. Most applications are not in a constant state of compromise, but quite often they seem to be under a constant state of attack. Attackers are often using the applications in a manner that has a large impact on the owners and operators of the applications. Your information security manager might be saying, well, you know, we've done all these things. You know, we've had the site pen tested. Not that pen testing is the only thing you ought to be doing. The OWASP top 10, we've got all that sorted. We've got a lot of processes and activities in a secure software development lifecycle. That's all coming. It all seems to be fine, but the other people in the business might be seeing a different sort of picture. Is this scenario familiar to anyone? Perhaps the business perception is at odds with sometimes what information security people are thinking about. And of course, as soon as you start thinking about these things, like Aladdin rubbing his lamp, there's normally someone who's able to come along and say that they can solve all the problems. So what is the problem? Automated threats. As I mentioned before, I'm a co-leader on the OWASP AppSecUSA project, which is about real-time attack detection and response in software applications. So in other words, self-defending applications. And one of the things that I'd sort of pondered on in that project were which were the best types of detection points for attackers. In OWASP AppSecUSA project, one of the ideas is to put detection points in which identify the intent of a user as malicious before they manage to do something very bad. So generally, it's trying to look for people who are perhaps hunting for vulnerabilities you may or may not be aware of, probably not aware of, and trying to detect them before they can actually find vulnerabilities and exploit them. But people are not just exploiting vulnerabilities or looking for vulnerabilities, they're also, as it happens, doing other things to your applications. And that was the area that I wanted information on to see how we might use AppSecUSA to detect these types of things. However, when I started looking around, it was a bit of a blocker because I couldn't actually find any proper categorization of these things, and thus no quantification of what the problem was. And when I spoke to various people, everyone had different names for things. Generally, it's bots, that type of stuff we're talking about. Even breach statistics, okay? Most breaches you hear about are about data breaches, where someone's actually had to publicly announce they've had a loss. I'm sure some of us know organizations, perhaps ones we even work for, that have had breaches of some sort or another, breaches of availability, confidentiality, integrity, breach of compliance, breach of contract caused through software applications, and not all those things are reported. So there's a big bias in sort of threat and attack statistics for things where vulnerabilities have been exploited. And in other words, generally breaches of confidentiality are the thing which get highlighted most in press and so on. Automation can, of course, be beneficial in general, and some of these types of things are being talked about in other presentations during the conference, in training sessions downstairs, and also some of the stuff we see on some of the vendor booths here today. But attackers are also using automation, and they're not just using it to fuzz the application or exploit a vulnerability. They're actually using your web applications as part of their business processes, and that's the area I needed more information on. So this type of stuff. In general, in terms of dictionaries and lists and things, tends to be too great a focus, I think, on individual vulnerabilities. And you see this often when people are aggregating data from their software development lifecycle security practices, quite a lot of the focus is sort of vulnerability driven, okay? Everything gets tagged as a vulnerability, possibly a weakness, okay? And severity ratings are then assigned to each of these vulnerabilities. But some things like these are quite difficult to put a traditional severity calculation on. They just don't quite fit in the same way. And some people will just not report these in terms of testing and other technical assurance activities for security. But the misuse of functionality has a large impact on operational costs, and therefore it's also something that ought to be in operational risk registers. But why do we really need yet another OWASP project? Well, there is a significant body of knowledge about weaknesses, vulnerabilities, and some conventions on naming. Not perfect, but people tend to agree on names for vulnerabilities. But misuse of functionality seems to be much less well defined to me. And it's often caused by design flaws rather than implementation bugs. Unfortunately, this has led to inadequate visibility. There's inconsistency in naming, and this has meant there's a lack of clarity in attempts to address the issue. People might be talking about one thing, meaning something else, and someone's providing a solution for something completely different. So what I decided to do was to just start another OWASP project. Anyone can start an OWASP project. You need very, very little things to begin with. You can contact OWASP, start a project. What I wanted to do was to identify, name, categorize, and provide guidance on how to defend against automated threats. So the first starting point was to get the name sorted out, and what we're talking about today is really the output of that, so an ontology of automated threats. I wanted to be vendor neutral, technology agnostic, and try to make it as relevant and as practical for website operators as possible. So I wasn't particularly aiming this at information security people. I want it to be in a language and a terminology and a level and a sort of granularity that operators of websites would use. So the sort of business management to business process owners. Of course, other people will use it, and I've got some scenarios which would help me explain how I think the ontology could be used. Well, obviously someone like an information security manager could help contribute to defining the requirements for perhaps a new website, say an e-commerce website. In the payments part of that site, they may want to avoid some types of automation threats, the ones we'll identify in the ontology, and these could be specified in a functional design document. And hopefully then when the company goes out to tender to get bids from various development companies to build this web application, they can specifically request particular answers to how the developers are proposing to tackle some of these issues. Okay. So that was one use case. I also thought that if we were able to actually tag threat information with the ontology names, it would be useful for things like a cyber intelligence sharing center in a particular industry sector. It would add more context to the data that was actually being shared between the organizations. And having a consistency in naming would then make it easier for people to be able to say, well, okay, we've got this type of attack from this source, it's causing these problems. Is anyone else seeing that? How can we share information and build, have some benefits to everyone within the group? Somewhat similarly, computer emergency response teams already have mechanisms and various data formats for sharing threat data. I would say it's probably, at the moment, the sort of data I see is perhaps a little bit weak on the application side. A lot of it is network type threats. And I think if the information of the threats could be tagged by particular automation threat names where possible, that would add greater value to the data when it is actually being shared. And of course, I touched on this one a little bit. A lot of pen tests, application pen tests and other assurance activities I see simply score severity on the common vulnerability scoring system, versions 2 and perhaps 3 nowadays, and they might often include mitigations and suggestions, recommendations for controls. Sometimes they're also mapped to MITRE's common weakness enumeration as well, possible weaknesses that are causing the vulnerabilities. But what I'd really like to see, and I try to include this in work that I do, is that some assessment of all these things that are found, some of these vulnerabilities might contribute to a tendency to be susceptible to some automated threats, and some automated threats may exist without vulnerabilities. What I'd really like to see is that type of thing appearing in pen test reports as well, because it adds a lot of value to the organisation that whose application is being tested. Some organisations with multiple applications can be spending far too much time dealing with the effects of automation. They might be cleaning up data, resetting customer accounts, and providing extra capacity during attacks. And all these issues can have a knock-on effect on customers, leading to negative feedback from them about the service and its availability. So we can imagine that the buying team would get some information from IT colleagues that define the quantity and frequency and magnitude of the types of threats that the organisation is seeing before they go out and start looking for some sort of service or product that might be able to help them in front of their systems. And the last part of that, from the vendor's perspective, perhaps a vendor's got some new product that doesn't really fit into any obvious product category or magic segment of some sort or other. If they could define the capabilities, if it's got some capabilities for protecting against bots, anti-automation type things, if they could define that and talk about it in a way that matches an ontology, then potential customers, clients and so on, could marry the things together and have a meaningful discussion and conversation about whether it's actually meeting their needs, rather than something which is a little bit up in the air. So I use these scenarios to help me think about the scope of the ontology. It's primarily about the abuse of functionality, so misuse of inherent functionality. Sometimes people might call that misuse of sort of business logic flaws, sometimes, although some of that is authorization type issues. So the ontology is meant to have absolutely no coverage of implementation bugs, because all that's been hopefully done already by other people. I also limited it to think about web applications only, because otherwise the field's just too gigantic. And it's also the area I know most about. So some things that are excluded, anything to do with mobile apps, for example, automation threats pre-deployment, something which affects the website but it's not necessarily web, so something like e-commerce return fraud, for example, that's not in here. Anything to do with other layer 7 protocols such as SMTP or FTP, DNS type issues around the web applications as well, and any network or physical environmental attacks. So, for example, I mean, currently in the press, I know it's not a web application, but all this sort of the VW engine software, which really is an attack against regulators, wouldn't be in scope either. Obviously, it's not a web application, but it's out of scope. It's an interesting area to explore, perhaps in another version. So I tried to sum up the scope in these couple of sentences here. So it's really answering the question in operations, what's happening right now? That's something, rather than who's attacking us, what's their intent, or immediately how are they doing it, or what weaknesses or vulnerabilities are associated with it. So that's the sort of level of detail that I wanted to get to. Of course, you might well ask, well, surely some of this already exists, and there might be some things on here where you think these automation attacks already appear. But if you actually look through them, they don't really adequately address these issues. And later I'll show you a mapping of the ontology I created against these, just to show you what that effect is. OWASP lists and other more specific exhaustive classifications also don't really have these enumerated. But I included all of these in my reading and research. So I started at sort of end of January, beginning of February this year, and I identified and read or skim-read 150 sources of information. They're all listed on the project's wiki page on the OWASP website. There was blog posts, news, vendor reports, breach reports, academic papers, white papers, technical papers, all that type of stuff. And from that, I got about 600 data points that I was sort of interested in. They weren't all automated threats, but they were sort of in the area of interest. And I posted some periodic updates to the project's mailing list. And there was a little item about it in OWASP Connector newsletter in April. And at AppSecUSA this year in Amsterdam, we also did a little flyer just to try to get a little bit more awareness out there. And I did also have some sort of questionnaires on the back about, do you recognize these particular terms and how often do you see them, that type of thing. But those 600 data points I actually put into a diagram because I quite like working visually with things. So on the next slide, I've got some shots of it. So it looks like that. Okay, so those of you at the back can't understand it, and I'm sure the people at the front can't read it either. So, this is available as a PDF on the website. So all my output of my research is sort of on here, and I try to sketch around sort of what the relationships might be. So it sort of looks like that. Okay. So you can see the. I tried to embolden things that I thought were potentially more interesting, possible clusters of things, and any sort of what I thought were sort of relationships between. Sniping and scalping. I wasn't too bothered about what the names were, and obviously there are some things on here which are outcomes and actually vulnerabilities as well, which I didn't really want, but I didn't want to lose the information at the stage while I was extracting information. But I found that as a useful way to gather the information together and make sure that I'd covered everything that I'd read. But from that, I got about 40 or so clusters of things, which I thought was about right, because I was thinking there was going to be at least 10 things, maybe 50, but not 100 or 200, something like that. So I tried to examine this, look for overlaps and unique aspects. And I gradually narrowed those down to provide some candidate threat event names, and eventually boiled those down to about 19, which became 20. But these are the 20 things that I've come up with for the ontology. Full details are on the project wiki, and there's a PDF which describes all of this. There's also a little booklet which I put together, which is the same as the PDF, which I've called the Automated Threat Handbook, which has got some pages about each of the threats at the back and a bit of description at the front. I got down to 19, ended up back at 20, which I'll touch on shortly. I gave each one an identity value, just hopefully so that people could, if it's useful, people could actually reference the numbers rather than the names. When I had 19, I just assigned all the numbers randomly because I didn't want anyone to think this is an ordered list. Okay, this is just ordered alphabetically. I didn't particularly want things adjacent number-wise that were related, and I didn't really want anyone to think that number 1 was the most important, number 20 the least important. Try to keep things 1 or 2 words long as well. I used OAT as a prefix, just to mean OWASP, automated threat, and obviously 3 digits gives me a bit of scope in case I ended up with 100 things. But perhaps the first digit position there could just mean web application. In the future, if we do a mobile version or something, we could start with in the hundreds or something like that for them. All these names really need automated web application in front of them, but that's an assumption, okay, when we're looking at this. But if these are used somewhere else, it's worth saying that these are only automated web application card cracking, for example. Cashing out, number 12 there. is cashing out using a web application, not cashing out using an ATM, for example. So just looking at the one that happens to be at the top of each of these two columns here, account aggregation was in that sort of 40 clusters I had originally, but I sort of knocked it out thinking it was really just a type of scraping. But when I started looking a bit more carefully at it, it did seem to be a particular problem in some sectors, and particularly in, say, the financial services area, the sort of having an aggregator as an intermediary between the bank and the account holder did seem to be a particular different issue that scraping didn't generally cover. So that one was added back in, and because that was the 20th one, it got code 20. The only name I made up from scratch, I tried to use names that existed somewhere, okay, was expediting, because I ended up with a cluster of sort of threats which seemed to, were sector specific or application specific, that seemed to do with speeding up multi-step processes. And without, I needed something quite general. If you start quoting a particular type of application or something that is expedited, I don't know, gold farming might be a term, it becomes unique to one application or one class of application. So that's the only one where the name was actually sort of brand new. Everything else tried to use names from existing literature, but of course part of this problem was that the names in literature were not consistent. So we'll have a look at a handful of these just now, but for each of them I've kept a record of what other people call them as well. So as I mentioned before, I really wanted something so that would be useful for operations type people in particular, something could then discuss with other groups. Some names were made more generic, so we have sniping, for example. Obviously auction sniping is the obvious case, but there are other types of sniping and timing attacks. Some things are particularly prevalent in certain sectors, so like carding or account creation, and some are larger buckets, which if I tried to break them down, they would sort of shard into multiple vertical specific threats, so things like scraping, spamming, and vulnerability scanning. I also try to avoid judgmental words in the terms, so the only one that's got the word fraud in is ad fraud, because ad fraud really does seem to be the industry name for that. Click and impression fraud for advertising, web-based advertisements. And the word fraud anyway is jurisdiction specific, okay? Not everything that is an automated threat is necessarily illegal in every country. It might be illegal in one. It might depend on contractual conditions. It might depend on the type of data. It might depend on the regulator. A number of the threats also seem to feel a bit more like cheating rather than being illegal. So there's a few things like, I suppose, expediting and skewing, these types of things. So fraud only exists in one term itself. So let's just look at a handful of them. So in the booklet, each page has got one of these diagrams. Okay. So we've got the identifier, the name, a summary description, a sort of diagram giving an indication of what's going on, and then down the bottom here we can see other names that sometimes appear in literature. So, so card cracking is the brute force attack against an application's payment card processes to identify missing values, typically for security codes or dates, where you've got the primary account numbers. So this is identifying missing data. Related threat is carding. This is slightly different. Okay, so someone might have obtained large numbers of credit and debit card data. They might have stolen it from some web application, some other parts of the business, or perhaps from a criminal marketplace. They would have bought them. And what they're actually, attacker is trying to do is to judge the value of the data. They don't know which cards are necessarily valid. They've got full sets of data, so they throw all the cards against an application to try to work out which ones might be worth exploiting further. Also known as card stuffing or credit card stuffing, or card verification. Similarly, but for authentication credentials rather than payment card data, credential stuffing uses known username password pairs, and often usernames might well be email addresses. Similar to the previous one, the data might have been obtained from criminal marketplace, or perhaps from some other breach data that's been published. And the idea is throwing all those credentials against your application to see whether any of those pairs of credentials have been reused. In other words, to try to identify valid account pairs. Lots of various names: account checker, account checking, account takeover, login stuffing, password list attack, and so on. So there's a few things there. So it's important to remember that both of these two are not brute force or dictionary attacks. They're actually using lists of data to check whether they are actually valid. Scalping is the mass acquisition of goods or services using the application in a manner that a normal user would be unable to undertake manually. Obviously, this is most well known in terms of ticket scalping, but it can be other sought after goods and services, something where there's some sort of limit to the number availability. Sometimes restaurant reservation booking systems can be susceptible to this type of thing as well, where people want to book particular restaurants where they're particularly sought after. And this type of attack can also, apart from cause problems to the owner of the application, in some ways it causes a denial of service to other users as well. And sniping I mentioned before, most well known of course is auction sniping, but I think the idea of this one is it will include all sorts of, sort of timing attacks where careful timing and then prompt action is required. So this is also something which is an issue perhaps in financial trading systems as well, placing bids and so on at the last minute. So hopefully giving you a sort of a feel for the types of things which are in there. Here are some things which are not in the list. Okay, so some of these were in my mind or in my diagram earlier that I thought that they might be. I had this thinking that consuming an application to perform business processes might be a threat on its own, but of course it seems that covers almost everything, and in some ways it's closely related to scraping in many cases. I also thought at the start we might have application worms in here, but of course because I'm trying to avoid implementation bugs, application worms are a combination of two implementation bugs: cross-site scripting and cross-site request forgery. So application worms are not in my list. There were also some things which were like collecting micro deposits or trying to get refunds, that type of thing, which I had this idea of calling it asset stripping, so taking something of value. But in essence, it's still a sort of data scraping type of transaction. And we've also got one called cashing out, which is obtaining cash and other high value goods. So that doesn't appear. There were a number of attacks where applications are used to attack other networks and other applications. And sometimes that was in conjunction with code modification, but both of those seem to be in the end due to lack of integrity checks at some point in the perhaps deployment or operation, and therefore I haven't actually included those. I do have spamming, but the other type of form hijacking, where people actually use a web form to actually send mail to random users, is excluded, because again that seems to be an implementation bug where there's inadequate input validation, so form hijacking itself is not in the list. I originally had man in the browser, but of course I realized that actually this is where the attacker controls the user's web browser, and for my scope that actually means it's outside the scope of the web application. I've sort of excluded the web browser from my thinking. It's very closely related, but it's not quite in my scope, I think. And I'd also thought about reverse engineering. In other words, trying to gain insight into how an application operates and how it's constructed. But that did really seem to be a combination of people doing footprinting and scraping type activities, and was more related to what their intended purpose was, which may not be obvious to someone at the time, and therefore you won't see reverse engineering in this list. Some people don't think abuse of functionality is a security issue, but really if you think theft of authentication credentials is, well, I think that credential cracking and credential stuffing are very similar. If you think theft of payment card data is a security problem, then so is carding and card cracking. And if you have problems with data integrity issues caused by skewing account creation and account aggregation, all those are also security issues. On a sort of more general point, if someone were to walk into your offices and sit down and start using your desktop machines and using your network to undertake activities, you'd probably think that's a security issue as well. Well, that's no different really to someone walking in and using your application to undertake their business processes in the same way. So let's just look at account aggregation in a little bit more detail. Lots of different names for this. This is a particular issue in, as I mentioned before, financial services, particularly online banks, where customers, the account holders, provide their login credentials to some aggregation business which interacts with the bank instead of the customer directly. From the customer's point of view, they see this marvellous dashboard with all their various bank accounts and savings accounts all together in one place. But it's a bit of a problem for the bank. They're sort of now not dealing directly with the customer. The credentials have been given to the intermediary. Do we trust the intermediary to protect those login credentials? Perhaps not as securely as the bank. We don't know. The bank probably doesn't think so. So now there's a third party involved which the bank has absolutely no relationship with. So on that, there's apart from account aggregation, there's probably data scraping going on, and that data scraping of the bank systems might not be something that they were ever designed for. They might be older legacy systems, expecting people to sort of click on half a dozen links in a session just to maybe do one payment transfer, something like that. But now they're getting pulled regularly by the aggregator to keep the data up to date. And those types of things can lead to instabilities and possible denial of service for other customers. So sometimes these things come in more than one at a time. Something else which is sort of similarly where there's multiple things happening, a criminal organisation might footprint an application, try to identify where the payment systems are, then use carding to identify valid cardholder data, and then perhaps either in the same application or someone else's application, once they've identified the valid cards, undertake cashing out to convert those stolen cards into actually to monetize it. And another example where there's multiple things happening which pen testers might be more familiar with. Doing pen testing, often you initially do some fingerprinting, you footprint the application, and then you start doing vulnerability scanning. The exploitation itself is outside the scope because that's exploitation of individual bugs. So moving back to look at where those threats in the ontology reference other things. So the Web Application Security Consortium's threat classification view, there's a large cluster of all these things here are within what I would say were WASP 42, abuse of functionality and insufficient anti-automation. WASP uses the term fingerprinting for both of these activities, and it's got a separate denial of service category. So you can see what we've really done is sort of drill down in this area. Similarly for the common attack pattern enumeration and classification, most of the issues fall within this abuse of functionality. KPEC does have separate footprinting and fingerprinting, and obviously denial of service as well. There were a couple of things which didn't seem to be in KPEC at all. And then there is some brute force specific attacks in KPEC. So the identified threats vary significantly in scale and their timing, durations and frequency. And obviously some of that is very data specific. So in the handbook I've listed which might be typical data that's been targeted in each of the attacks. And for 3 of them, I've just put 3 of them on here. So there's a number of threats which do affect payment card holder data, some for authentication credentials, other financial data. These are mostly allocated to other data types as well. I also try to list who might be affected by these attacks, and it's not just the application owners that are affected, okay? Application owners might be affected by lots of them. Sometimes individual users, third parties are affected as well. So I find this quite sort of a useful viewpoint. If you're undertaking a risk assessment, you might typically be undertaking it from the viewpoint of your business. So what's the effect on your organisation? A regulator might be looking at it and going, well, what's the effect on consumers, or what's the effect on society, something like that. And some of these things will have different impacts on those groups of people. Returning to one of my original questions, which was which detection points in the OWASP App Sensor project might be useful for looking for these things, well, it turns out, perhaps obviously, that system trend exceptions and user trend exception type attack detection points are the things potentially of use for detecting these things. Vulnerability scanning, there's quite a large overlap with lots of different categories in App Sensor. If you do want to learn more about App Sensor, my colleague John Melton is speaking here tomorrow afternoon about the project, so do come along and listen to that. And returning to my original slide with the Information Security Manager and the COO, perhaps now they can actually talk with some clarity by actually referencing particular threats in the ontology. Other parts of the business can then also reference these. Possibly even risk assessments will then can use information in the handbook to develop threat scenarios and look at what the impact is on the business. And of course, use this information like in one of the scenarios where we can use the data for intelligence sharing. Then, as I mentioned before, if Aladdin rubs the lamp, perhaps in the future we might see some vendors appearing armed with evidence about how they can specifically address these particular issues rather than just the we solve it all type answer. All the information is on that URL, or just search for automated threats. You'll find the page. That's what's on the wiki. At the moment, it's primarily naming and cross-referencing that's against these. What I really want to do is add things for designers, developers, and operators. How to defend against this type of thing, and I think that might be easier doing it one sector at a time, because I think there's going to be perhaps difficult to do it overall. On mitigations, I suspect we've got some mitigations which might be relevant for lots of threat events, typical sort of anti-bot type measures, and then there might be some mitigations that are very specific to particular threats. And the other thing to always bear in mind is I'm always interested in who are the perpetrators of various things. And again, this is probably going to be sector specific. And we saw some things where the threat was actually the users. So for example, account aggregation, albeit it was via a third party. But these are the types of groups which I would tend to sort of start looking at if I was doing a risk assessment of an application. And it's not just organised crime. There's plenty of other people interested in doing things to your applications. Some other people have obviously contributed. Thank you very much to them. I think there's some of them in the room. Anything that's wrong or mistakes, and there are a few typos and things in this which we're going to fix. That's all my fault. So it's version 1.0 at the moment. I think now we've got some bit of time for questions. I'm also going to be around at the social event this evening on the boat if you want to ask me things specifically, and also around during the rest of the conference.
So first off, that was a very original content and nice slide. So thank you. Please give him a warm round of applause. We got 10 minutes for questions. So if you want to ask questions to Colin, please come to the microphone in the front. It supposedly works. And this is it. could you explain me the difference between fingerprinting and footprinting? Because I've never heard of this before.
Yes, okay. So the reason I came up with and kept them separate was that KPEC has them as two separate identities. OWASP actually just calls it fingerprinting, I think they call it. Okay, so I would say fingerprinting is just testing for specific, perhaps URLs, looking for, is this an ASP application, is it .NET, that type of thing. So just a very superficial, not any sort of exploration really, just looking for particular sample data points. Whereas footprinting is more to do with actually going beyond that and starting to enumerate the whole application. What is all the functionality? Where is it? What are all the paths and patterns? So I think actually it suited me to have them separate as well, because fingerprinting is probably a really low impact event, but actually it gives you quite, if you see it, you think, oh, that's really interesting. Why does this person think I've got a PHP application? You know, what are they doing? You know, it's clearly not my application. So I think it's a different indicator, whereas footprinting would generally start trying to abuse the whole application in some way, trying to crawl all the way around it. If there are no other questions, that's fine. Oh, there's one here.
So you mentioned that by classifying these threats, you envision that, you know, pen testers and application assessors would be reporting these types of things. How do you see them, or how do you see them reporting these things, and how do you see the consumers of the reports understanding them in the context of the report having vulnerability threats of pretty high severity alongside these automated threats that everyone knows exist, but it's hard to say, yeah, here's how you're going to get exploited?
Yes, so thank you. I think what I would suggest is that having all the vulnerabilities, that's fine, and rank them critical, maybe high, medium, low, and so on. But everything else should also be added there as perhaps just call them information-only findings, okay? But then somewhere forward in the report, there should be some assessment by the penetration test company then saying, okay, given all this stuff that we've got, which things are actually most important to the business? And actually sometimes those things might be information-only type findings, but it needs to be discussed and explained. So what I would tend to do in pen test reports is have a listing based on severity, but also but actually we think you should address the issues in this order of priority, which could be something completely different from the severity. And that does mean that the testers need to have a bit more knowledge about what the potential for harm is to the organization. So I would think it's probably an extra section in the report, but something that looks at combination of vulnerabilities and also these automation threats. But there might be other things in there as well, like, some compliance failure. That's not necessarily a vulnerability, but it's if you come across it when you're testing a site, you ought to mention it.
Any plans for next steps? Are you going to have like a detection technique section or go beyond the ontology?
Yes, okay, so the only thing beyond so far in the handbook is we've put possible symptoms. And what I'd really like to do is to go through each of these and start looking at what are the mitigations that, in particular, developers could do. I think that's probably the most interesting area to start with first. What things, perhaps they should have example security requirements, write those out, that might be a starting point. And it is really something I'd like other people to help with, because I don't know it all myself. I've just sort of done this much. I can start guessing some of the rest of it, but really I need some input from organisations that have seen these types of problems a lot, and what did they actually do to help. Okay, so if you're on the boat this evening, I'll have some of these with me. I've got about 20 copies to give away, so come and find me. It's available as obviously PDF, everything. You can buy this for, I don't know, $10 or something on the from Lulu, but the PDF and everything's free on the website. So if that's it, thank you very much. Thank you.